All right. Hello and welcome, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us today. My name is Sarah Alspaw, and I will be your webinar host. And I am coming to you live from Cincinnati, Ohio, here in the U.S. I'd like to officially welcome you to our webinar, our topic, Chasing the Dual Mission of Product Cost and Carbon Emission Savings. Before we begin, we'd love to know what brings you to this webinar today. You should see a little poll here on your screen. If you don't mind, just take a moment to respond there. Also, as you know, Siemens is a very global company, and we would love to hear where you're joining from. So feel free to say hello in the attendee chat and let us know your location there. We'd love to see where you're joining. Like I said, I'm coming to you live from Cincinnati, Ohio. So we are on Eastern time here today. But again, we'd love to hear what part of the world you're coming in from. So feel free to say hello in the chat. I see a few responses coming into the poll, so thank you for that. I'll leave that up for a few more seconds. But if you're just joining, please let us know what brings you to this webinar today. Also, feel free to say hello in the attendee chat and let us know your location. And then I'll have a few housekeeping items I'll get into, and then I'll turn things over to our presenters. And seeing those poll responses trickle in. Again, thank you for those of you who have answered that. I'll give you a few more seconds here. Brazil, welcome. Thank you for joining us. And again, welcome to those of you just joining. Feel free to say hello in chat. Let us know where you're joining from. Also, we have a quick poll if you don't mind letting us know what brings you to our webinar today. All right. Well, I'm going to go ahead and get into some housekeeping here. At the bottom of your browser in the center of your screen, you should see icons in a widget dock, and these are the interactive tools you can use throughout the webinar. You can minimize, maximize, and scale each widget to customize your viewing experience. I'd like to call your attention to the Q&A widget. The Q&A Ask Questions window should be open, and this is where you're encouraged to submit questions to our presenters throughout the webinar. You can submit your question at any time, and we'll save it for our Q&A at the end. Do know it will look like your question disappears, but we'll still see it just fine on our end. Also, there's a help icon in that widget dock. If you have any technical difficulties, click on that. But do know that a refresh of your browser and On24 will solve most technical difficulties, so definitely give that a try. Also, this webinar is being recorded, and you'll receive a link to view the recording within 24 hours after it ends. All right, let's see our locations here. Welcome, Germany, UK, Germany, Mexico, Belgium, Brazil, Spain. Welcome, everyone. And again, welcome to those of you just joining. Feel free to say hello in chat. Let us know where you're joining from. Okay, a little bit about Siemens Digital Industries software. Siemens Digital Industries software helps organizations of all sizes digitally transform using software, hardware, and services from the Siemens Accelerator business platform. Siemens software and the comprehensive digital twin enable companies to optimize their design, engineering, and manufacturing processes to turn today's ideas into the sustainable products of the future. From chips to entire systems, from product to process across all industries, Siemens Digital Industries software accelerates transformation. And real quick, before we jump into our presentation, I just want to give a heads up to those of you in Europe or perhaps China that are joining us today. We still have Realize Live coming up in your part of the world, so head to realizelive.com and you can get more information and register there. And I would like to welcome and introduce our speakers today. With us, we have John Monica and Victor De La Vera. You can read their bios at any time in the bios widget. There's a little blue arrow there. Just click on that to expand to read more, and you can learn more about them at any time during the presentation. But I don't want to take any more time away from them, so I will go ahead and turn things over. John, I know you're kicking things off today, so I will hand it over to you. And welcome, John. You now have the floor.
Okay, thank you, Sarah. Yeah, so thanks for introducing us. Victor and myself, we're in a group that we deal with pretty much every customer we talk to within the America zone. So I think we were talking beforehand, And over the last 14 months, I think between the two of us, we've talked to 70 different companies in multiple industries. Today, we're really focusing on the automotive industry, and we're talking about product cost and carbon footprint emissions, scoring both or calculating both. Okay. So what I'm going to do is I'm going to start things off. I'm going to talk a little bit about the current state of the industry and what we're hearing from other companies. Again, many of the companies we're dealing with one-on-one. Then we'll talk about where are we headed from a vision standpoint, very briefly. And then I'll go over a few slides to talk about the solution overview. Team-centered product cost management, costing tool that calculates both cost and carbon footprint for product or system or assembly. And then what we'll do is I'll hand off to Victor, and he will take us through a demonstration of some of the aspects of the tool, and we'll actually be able to see inside the system. Okay, so to start with, if I can learn how to advance these slides, what are we seeing out there? A lot of companies talk about challenges, a lot of presentations talk about challenges. So what are we hearing and what are we seeing, especially in the automotive industry? What we're seeing is changing consumer expectations impacting the auto industry. And I know that's been said a lot in my lifetime over the last 30 years, but it really is having an impact today. At the same time, what we're seeing is an accelerated pace of technology changes. So a lot of technology changes, a lot of pull going on in the industry, the auto industry, as well as a lot of push. But how do we keep up with these technology changes? We're also here, and part of what we're here to talk about today is the sustainability impact. How are we accounting for that? How are we reporting it? How are we calculating it? And then the next level is integrated intelligence, or what I'll call AI, software impact. Just look at the vehicles that are produced now versus 10 years ago. It's amazing. And then finally, what is the regulatory impact on the industry? And that is something that's not going away. If anything, it's growing year to year. Okay. So what does all this mean? What we're seeing, and we deal with, again, we've been dealing with a lot of companies that are trying to apply what I'll call a traditional approach to cost management and practices for cost management. They're trying to apply the same techniques they might have been using for the last 15 to 20 years on this new set of challenges they're faced with. But what they're running into, and what we hear a lot of is, for instance, the very first bullet on the left hand side is no calculation history. So with new technologies being introduced, there is no history. It's not like we could go back and do 40 years of costing out a brake caliper. This is new technology, and it's a challenge for companies. Likewise, what we're seeing and hearing is the data that's needed to complete these calculations, not just for cost now, but for carbon footprint as well. So data flow cannot easily be tracked or traced. And the fourth bullet here, data has a high potential for inconsistency. So how do they get to that consistent level, in the data flowing through their system properly as they need it to be? And then what we see quite a bit of as well, a lot of manual human effort going into the calculation process, into the cost management process itself. Okay, so where do we go with this? When I look to the future for this, and we've seen variations of this slide over time, but what we're actually experiencing is pressure on the product development process. There's been pressure for a number of years, but I would gather to say there's a more intense pressure now, especially with the introduction of carbon footprint calculations. So where we are focused is in this development cycle, shifting the capability to the left so that we can understand the cost, we can understand the carbon footprint of a product or an assembly or a system, like I said, very early in the process, so that we can make decisions and do trade-offs as needed to actually impact the design of the part and eventually the production of the part. Okay, so everything we're doing today is in light of this. So when we get into the solution, team-centered product cost management, in support of that development process, this is where we play. We play from everywhere from concept, when a part or a new technology or an existing technology is a napkin sketch or an idea in somebody's head, all the way through production. And we through that production, what we're doing is allowing companies to balance the cost of the product against the carbon footprint score for that product, and managing that balancing act or the trade-offs that are being required. So, and it doesn't matter what the use case is. There's three primary ones listed here, but it could be the costing and calculation of carbon footprint of a part someone's purchasing. It could be the part they're making in-house for quotation. It could be many different use cases, okay? But the main takeaway here is this is where we're focused on that product development process. So if we look at team-centered product cost management, it's really broken up in 4 different areas, okay? We focus on product costing or part costing, a lot of different ways to describe that. We can also do tool costing, which would be things like stamping dies, injection molds, high pressure die cast molds, other technologies as well too. But 2 separate modules there. We also have the ability to calculate do a profitability study on any project. So that could be a combination of many different products, many different tools. It could be a standalone product, and we can calculate the profitability of that. And then what we've recently, I wouldn't even say recently, what we've added in the last few years is the ability of the system to calculate a carbon footprint score for that part. And we've put this capability into the cost tool just for that purpose of allowing companies during the development cycle to balance cost against the carbon footprint score as that part is going through its development evolution, if you would, okay? And allowing companies to hit targets for both or optimize both calculations. So I'll move on to the next one. So what does this all mean? So what team-centered product cost management is a calculation engine here in the middle of this slide. We have a lot of different functions that the tool can be used for, anything from versioning, which is critical to managing that cost throughout that product lifecycle. It is a simulation tool. It can be used for analysis and comparison analysis, as well as visualization and reporting. So we have the ability to take the data that's produced out of the system results and send that off into business intelligence tools, into different dashboards and different reports, really focusing on what is the use of this costing effort that we're doing, okay? And what this calculation engine relies on then is a lot of data, okay? Anything from part-related data, which could be the bill of material, CAD data, the bill of process, as well as other cost data, raw material costs, purchase part costs, labor rates, and burden rates out of the plant. And this data comes from different systems. And so we're really focused on the integrations, and I'll talk about it in a minute. How do we bring all of this data into a single cost tool so the user does not need to leave the tool to complete the work that they're doing, whether it be, again, simulation or managing that cost throughout that product development process. And then off to the left, what are the results of all this? It's supporting different use cases. And of all the companies we talk to, very few have the exact identical use case or use for the tool. But the primary ones that we see are preliminary costing, cost and carbon footprint, maybe we call it target setting, quotation costing for parts that are manufactured in-house that'll be quoted to that customer of ours customer, as well as supplier costing, which is costing the parts that they buy from their suppliers, okay? So if I move on to the next one, and I told you I'd talk about integrations and data that's required. So where do we get all the data from? When it comes to part-related data up here at the top left of the slide, this would be what we call PLM data. We have obviously, we're team-centered product cost management. We have a high level of integration to team-center, but that part-related data could be the import of a bill of material for the costing process, a bill of process, or import of geometries. All of that used in the costing process. And then on the right-hand side, what you have at any given point is data that we usually represent this coming out of an ERP system, but this would the data that would reside in the tool at all times and be kept updated at whatever cadence our customers desire it to be. And this would be things like, again, it could be plant data out of your plants, it could be raw material costs, it could be purchase part cost. So, and the plant data could be things like labor rates and burden rates, We also have the ability to import a bill of process from an ERP system, as some companies track their routings and control their routings in an ERP system. Okay. Something new that we've come out with recently over here on the left is transportation data. And we have now the capability to integrate directly into the Siemens digital logistics software. And we can send a bill of material into that system. And what it'll do is it will calculate the transportation required, both from a cost and a carbon footprint standpoint, okay? And bring that back into Teamcenter Product Cost Management. We have the ability to then interface to other systems that we can send data out into. We do this through a series of APIs that we have developed. This allows us to go into other PLM systems, other ERP systems, and we can get that data out and into our system, as well as other enterprise systems like CRM tools. Okay, this may be where we're bringing in vehicle volumes, so that customers of ours don't have to key that sort of data into two separate systems. It can be keyed into a CRM tool, and then we can integrate. We have integrated where we pull those volumes into the system. Okay. So another one we talk about data is the data that we supply with the cost tool. So this slide represents the data that we have, that we do provide. So over on the far left, when we talk about costing content, we supply production site data from around the world, 550 regions. And this is everything from labor rates, floor space cost, interest rates, utility cost. So this is data that we supply, that we do the research on, and we provide this to our customers, primarily when they're costing the parts that they're purchasing. And they may or may not know who they're going to be buying from, but they can zero in on a specific region. They can run sensitivity analysis and create an estimate in one country and very quickly move it to another country to do that benchmark analysis. And now combined with that Siemens digital logistics integration, they can actually land that part at different or at one location and do a comparison of landed cost by region. With the data that we supply that's specific to site, we also supply machine data for 4,500 different machines right now. And what this data is, the two of them combined give the ability to calculate a burden rate for that part for each operation in that manufacturing process. So the machine data we provide is things like floor space required, utility consumed. So basically the machine data or the machine information that we supply consumes the rate information. And that's what allows us to move that product around the world. We can keep the machine consistent and move a product from one country to another country, one state to another state. And what we're really doing is moving, when we make that move, is we're changing the data that's behind the system. Some of the other pieces of data that we supply with the system, we also supply 1,200 different substances, and this is not just material specifications. This is manufacturing properties with those substances, and that's used in some of the cycle time calculators we have embedded in the tool. We also provide a process library, and this is a process library of what most companies call it a best practice folder. And what it is, it's the processes can be dragged and dropped into an estimate. So if somebody's not familiar with a specific process, they can go out and grab the canned process that we provided and reuse it. It'll interact with the CAD data from the part. It's a costing aid that helps with the calculation process. Okay. We also supply material prices and overheads from around the world. From the material prices are for over 10,000 separate material specifications. And then something, again, fairly new, we keep saying it's new, but it's been 3 years. We also supply carbon footprint data that facilitates the calculation of a carbon footprint score or value for a given part, assembly, or system. Okay, but this is the data that we supply with the system. So how does this whole thing work then? What does it look like, or how does everything interact together? And in short, just walk through this very quickly. What we're bringing in is product data, or the scope of what's being calculated. Okay, And that could, when I say product data, that could be CAD data, that could be the bill of material, it could be the bill of process. Or we can also start the process with nothing. We can start the process, like I said earlier, with a napkin sketch and the use of a surrogate. So a company can very early in that product development cycle begin the costing process. Then what we combine that with, or we bring in, is the plant data as needed. This would be labor rates, like I'd mentioned before. Then we calculate a material score for the part. That's the real focus of this, is what is that material value of that part or system that we're costing. And it could be a roll up of the purchase parts, those values that are pulled in from an ERP tool. It could be the calculation of a fabricated part using raw materials in that estimate. So the focus here though is on all the inputs that go into that material calculation. Then there's the manufacturing process. Again, this could be anything from identifying each manufacturing step. And we have different ways of controlling this. We have different ways of bringing the bill of process, if you would, into the system. Or it could be created from scratch as well too. So we're not limited to that. But this would be everything associated with each operational step. Everything from cycle time to scrap could be captured here, setup times, all of that. And then there's the application of overheads. And it is a highly configurable, flexible system. So again, each company we deal with is sometimes slightly different, sometimes quite a bit different. But a lot of companies have different material overheads, different manufacturing overheads, and post-manufacturing overheads. And we can configure the system to capture those and allow the users to apply those. So in short, what it is in the costing process, it is a calculation of the material, of the operations, and the application of overheads to get us to that final product cost and carbon footprint calculation. Okay. So I'm going to be done talking now, and I'm going to hand this over to Victor. Okay, and he'll walk you through a demonstration of what the tool looks like and how it functions. Okay. Yep.
Okie doke. Hi, everybody. Hope everyone's well in all parts of the world. I'm going to play some videos for everyone that will get into and demonstrate the tool itself, as John mentioned earlier. And I'm going to turn off my video if people don't mind, just because I don't want it to interfere. So the first slide is just an explanation of the 3 videos that are coming up. So we're going to import bill of material from Teamcenter in the first video. We're going to do an integration of electronic pricing from Supply Frame. And then the third video in this group of videos, we're going to do a creation of a business case and show a profitability analysis within the tool. Okay. So this is the first slide, and this is the train rolling cargo wagon. It's a bill of material and a geometry coming over from Teamcenter. So yep, so you can see right now, this demonstrates where it starts by showing we're in Teamcenter. So the BOM is in Teamcenter, and we're using a main assembly that has to be analyzed from a cost and carbon footprint perspective. So now we move the cost right into the tool itself. We're going to import the BOM as well as all of the geometries as well. So everything is brought into the Teamcenter product cost management tool, ready for costing. And so you can see all the geometries. This is the import from you can import a BOM from a spreadsheet. You can import a BOM from Teamcenter, any kind of cost breakdown. You can do a custom import. and then after the import, so the user has relevant data in Teamcenter Product Cost Management. In addition to the BOM, the related CAD data were imported into Teamcenter Product Cost Management for visualization and calculation purposes. Sorry. So you can open up, and when we create a new calculation, so you can see the quick editor and the controlling BOM view in the window. So here we're going to define a manufacturing location. So we can choose a plant in different areas of the world, if you like, and you can pick any type of region and any manufacturing location. Okay. And it's as simple as that. It's as simple as clicking a couple of buttons and you move into another location. You can also drag and drop various parts from the knowledge domain, as John mentioned earlier. You can build a knowledge domain, and so it's a very simple, very easy to use tool, and you can basically store calculations and historical knowledge. So as people leave the companies, you still have that cost knowledge embedded in the tool somewhere. Okay. So this is flexible calculations. So this is with an activity editor. So we're able to import large BOMs, all relevant data for a calculation available in one single solution, right? Flexible calculation updates, import large BOMs, as I said. Okay. So now we're gonna go to the second video, which is the integration of electronic prices from supply frame. So in this video, we're going to show the integration of electronic prices from supply frame into Teamcenter Product Cost Management. And it just takes a couple seconds to load. So companies can import the latest electronic prices from supply frame to do all sorts of what-if scenarios in any phase during the product life cycle. In our demo, the cost engineer is automatically calculating the cycle times, right? So that's the cycle times are being calculated in as well. And you can see as the import back from supply frame, you get manufacturing, locations, the pricing, and as well as some carbon footprint. Teamcenter Product Cost Management, together with supply frame, helps leading electronic manufacturers and distributors accelerate new product introductions, reduce supply chain risk, and take advantage of market opportunities. Okay. This third is a rather long video. This one is explaining the business case for profitability. So module as well in the tool, and this allows you in the early phases to take assemblies or products, put them all together in a project, and it allows you to do an analysis, financial analysis on all of the parts. So the user gets a complete view of the calculation from an in-house main assembly. And including all the calculations. So you can see the purchasing assembly for the outer casing and the transport calculation for the buffer assembly. So let's see. So it allows you to change parameters as is needed, business case. And then you'll see this is the calculation. And then there should be some graphics popping up pretty soon. So this is a simulation. So the user is from the profitability analysis for the main assembly, and they're basically dragging and dropping an existing calculation into a new business case. Here we go. So it shows you the graphics at the bottom, and this will change as we change. So as we make changes, you'll see up-to-date information coming in. So within the profitability analysis, the user examines key performance indicators like working capital, profit and loss, and the results, including net present value, internal rate of return, and amortization period after the start of production are presented graphically as shown. Cash flow, discounted cash flow, and then additionally, the users will review annual requirements as well as, and they can adjust surcharges, they can adjust capital. So in this case, you can see dedicated equipment versus non-dedicated equipment, and all this can be amortized into the, as the user sees fit, amortized into the products, or into the project. So here the user reviews the special payments for tools and has the flexibility to adjust the tool investment amounts as needed. And then we're also going to simulate, these are simulating material prices. So we can alter material prices based on the year, so we can profitably during the new product development phase. Users can add assumptions, and you can visualize the results, net sales price over the project's lifetime for the buffer assembly that we're showing. So in this demo, the user simulates the material price increase and updates the project calculation to observe its impact and the net present value, right? And then we also have, we're also going to show cost factors, activity rates, overheads, and exchange rates as well. So the user is now reviewing various cost factors, imputed interest rates, the cost of space, electricity. Next, they examine activity rates and overhead rates, such as material overhead rates, residual manufacturing overhead rates, and the allocation of part-specific development costs. And then at some point, we can also, we also have exchange rates in here as well, because that's part of the profitability. So Team Center support for finance in the field of a comprehensive profitability calculation with the unique approach of merging calculation, planning, and profitability calculation on an integrated platform. Changes in cost due to investments for producing a product are automatically reflected in the calculation. KPIs, net sales price, it's all automatically reflected. And you can see these are the exchange rates as well at the end. So I got a little bit ahead. I got a little ahead of the video, but okay. Next, we want to talk about 3 more videos. So here we're going to show the creation of a calculation for a purchase part, the calculating of inbound transportation or landed cost, and then we're going to compare some supplier breakdowns between supplier and contrasted with the internal should cost. Okay. So I'm just going to start this video. This video is the first one in here is the creation and the simulation of a bottom-up cost estimate. Okay, so the cost engineer is creating a bottom-up calculation to analyze the optimal cost of the CO2 and CO2 footprint for the subassembly called the outer casing. And this would be as if we would be purchasing this. So this is a should cost, in other words. So in the first step, the user is picking the geometry. So we're going to there we go. We got the geometry. So this is a newly created bottom-up estimate. So we're leveraging, now we're looking into the knowledge domain, and we're going to drag and drop information right into our calculation. So we offer a comprehensive database and a reference data like labor costs. It all enables very quick simulations for shifting production to different countries or regions. It also includes physical data for common materials used in cycle time calculations and material pricing. We also provide a technical and commercial data for over 400 machines covering standard manufacturing technologies as an example. This is a simulation on material. So by opening the material calculator, adjust the sprue or the overflow weight, we see an immediate effect as the increase in cost and CO2. So you can see all that immediately. We're going to change the material from one aluminum composition to another. It shows a decrease in cost and CO2. And you see it immediately on the screen. So what we're doing right now is we're taking you through each of the individual different methodologies or attributes within the tool that allow you to change and balance the cost with the CO2. This is a simulation on the machine. So now we're going to show you the direct impact and the reduction in cost and CO2 when switching from a larger to a smaller machine. So you'll see all that information as it comes in within the machine as we change the machine up in the upper right-hand corner. So here we're just picking another machine, and it pulls in all the data for that machine, all the electricity usage, the square footage, all the information comes out of the database. It's all stored in the database. So this can all be done on the fly, if you like, while you're discussing with a supplier, or to create a should cost. And then you can see in the upper right-hand corner, it shows the reduction in both cost and carbon footprint. Okay, now we're going to move the part. So now we can simulate the manufacturing relocation from Germany to Czech Republic, as an example. And this will show a reduction between the cost and carbon footprint. So a further relocation simulation to Romania as well shows a further reduction in cost and CO2. So we can continue to use the tool and all the aspects to reduce both cost and carbon footprint as we move the part. Of switching from an electricity mix to a green energy source, and that shows a reduction as well. And the user can also change, we can also change the carbon tax factors as well. So obviously there's a carbon tax on some things that are being, and it's all incorporated in the tool. So as part of your cost, you get the carbon, you have to put in the carbon tax. And then finally, we can report the results. They can be reported in a diagram, and they can show the current price, annual volume, contribution margin, price, carbon footprint. Okay. So the next video is going to be the inbound transportation for purchasing parts. So this would be related to a landed cost. So the transport calculator, the cost engineer would open up the transport calculator to calculate the cost and CO2 for inbound transportation. And in this case, we're going to go from Turkey to Germany for a purchase part. And the purchase part's called a buffer spring. So we're the original destination, the from and to, and the transport modes will show up. So road, air, sea, and rail are available within the Teamcenter Product Cost Management tool. And you can see it also provides a map, quantity or weight is editable in the shipments field. And these data are exported via cloud service to Siemens Digital Logistics. So in this tool, the cost and carbon footprint for the requested transport are calculated and sent back to the Teamcenter Product Cost Management tool. Teamcenter Product Cost Management automatically showing the best solution. And then we can do further analysis. So you can, the engineer can analyze various legs from different locations. So the user, the engineer, cost engineer can alter the transportation within this module and show what the best solution is relative to, again, always balancing cost with carbon footprint. So they can do different simulations, road, air, sea, and rail, and see the impact immediately. So switching to sea mode may increase carbon footprint or decrease carbon footprint, but increase cost. So finally, the product cost manager provides the results in a comprehensive overview, right? So the procurement team, if that's who it was, could annualize the full round trip impact of buying parts from various suppliers all around the globe. And supply chain managers can weigh the trade-offs between using the higher cost supplier or less carbon footprint. So the third and the final demonstration is going to be the video where we export calculations into detailed cost breakdowns and import suppliers' cost breakdowns as well. So in this case, you can send information out to suppliers. Hang on, I think I lost the video somehow. So did we lose the video, Sarah?
I'm not sure. I'm looking right now. Give me just a second. It looks like the last one was number 5, so we might be missing one. I'm sorry. Let me see if I can get
Okay. Skip over the last one. The last video showed what we were trying to show was that you can within Teamcenter Product Cost Management, you can send out a cost breakdown to as many suppliers as you like. You can bring it back into the tool and then for an analysis of each of the suppliers. So you can effectively review all the suppliers' information, and you can compare information with the supplier's information, or you can also compare your information between each of the supplier's information. So that gives you a better understanding of how the tool works or how the cost is being created and within each of those different suppliers. And you can update your own database as well with that information. And you can, and it also, the breakdown also has the carbon footprint as well. So what we'll do is with the new, whatever we send out, we'll send you the video for that as well. Okay, and the only other thing I want to say about the video is we can do more than one breakdown at once, and you can send the breakdown out to the suppliers with a blank, so it has nothing in it, or you can send it out to the suppliers as you may have filled it out. Okay.
Victor, I found it if you want to play it. It's
you got
the next
it.
video.
You got
Yep.
it.
Sorry about that, everyone.
That's awesome. No, we can play it real quick. It's playing right now, right? So there's the breakdown, and you can see it goes out. You can send it out as filled out. So you can send it out with your should cost to a supplier, or you can send it out blank to the suppliers, and you can see here's all the different the amount of information within the breakdown. So it's quite extensive, right? There's a whole page for material, a whole page for material and overheads, and this is the summary page. And then once you import all those back in, you can import them in as an individual supplier. You can import them in as, all 3 suppliers if you like, or 4, however many suppliers you care to review. And so here we're starting the cost breakdowns and import. And now we're going to choose all 3. And we're going to compare all 3. So we've got them in now. And now you can see the offers can easily be compared for cost drivers as well as negotiation, right? And that's the idea here. And then following that comparison of offers, the cost engineer can dive deeper into specific cycle time calculators as well. So we can, and as a result of those details, you can update your database relative to that supplier. Okay. All right, so so we've created what we believe is the best solution in the market. And it covers, as John said, 4 main areas, right? Product costing, carbon footprint, tool costing, profitability, which is all related to the life cycle of the product. So 3 simple things to remember relative to management. 75% of our over 400 customers are in the automotive space. TCPCM is the only solution that addresses the complexity of calculating cost and carbon footprint at the same time. And TCPCM has an internal content team as well as third-party data providers, and that's related to the master data and the CO2. They're updated every 3 months. Primary use of the tool, again, we're not limited to, but the primary use is cost and carbon footprint, supplier cost and carbon footprint negotiations, and as well as the quotation calculator. The tool is designed for fast setup and configuration and easier operation, and it offers a robust set of features and functionalities, hopefully as you've seen it through the course of this. Okay, so I'm going to say thank you for your time, and we can move right to questions.
All
Okay.
right, great. Thank you, Victor. Yeah, we do have time to answer a few questions here. So attendees, I'd like to encourage you to please keep typing your questions into the Q&A Ask Questions widget. We will get to just a few of these here. If we don't get to your question, we will follow up with you offline. All right, let's see here. Our first question, what are the data sources for cost in CO2e?
All right, great. Well, you know what? That question gets asked a lot. So we have global cost data, labor rates, floor space costs, things like that. They're all Siemens researched and validated. So we have a team of people in Siemens that research and validate labor rates and floor space costs and things of that nature from around the globe. And then we also have machine costs and CO2 data, which comes from CostMine for cost data and Sustomize for CO2 data. So Sustomize is the company that's a third-party sourced, as well as CostMine for cost data. And then all of our CO2 data does come from Sustomize. Okay.
Great, thank you. All right, our next question. What integrations to other systems do your current customers use?
Okay. So we're very highly integrated into Teamcenter, and it's bi-directional. So CAD data, BOMs, bills of process, all that can come in from Teamcenter, obviously. But we also have APIs that facilitate the integration to other PLM tools as well. So many companies require integrations into ERP like SAP, and that would pull in material cost and plant data cost as well, plant cost detail as well. So we can also integrate into those, into any ERP system. And we've also recently integrated, as you've seen, into Siemens Digital Logistics to calculate the cost of the transportation and CO2. So that's a landed cost. So now we have the ability to integrate directly into our digital logistics tool and get the calculated cost of transportation and CO2, so you can effectively move the parts all over and understand the CO2 impact relative to transportation and the cost impact. And then some companies have required integrations into other enterprise systems like CRM tools as well. So we can integrate into just about anything. And we've even pulled things in through Excel, right, which is everyone's favorite cost tool, quite frankly, or the mass cost tool out there is Excel, right? Everyone uses Excel. So we can bring things in. I think that's the biggest takeaway from that question. Okay.
All right. Thank you. Again, attendees, you can keep your questions coming in through the Q&A Ask Questions widget. I'm going to squeeze in one more question here for you, but we'll get to the rest of these offline if we did not get to your question. Can you separate the cost software from the CO2e?
Yeah, so this is a question that we get asked a little bit. The cost capability can stand alone, but the carbon footprint calculator cannot be separated from the cost tool. And I'll just elaborate just quickly on that. The way the system works, there are key elements in cost that are similar to the key elements of creating a carbon footprint. So, or calculating the carbon amounts. So those key elements are integral in this. So if you run your machine for an hour and that machine is located in China, that has a specific carbon footprint that we're using to calculate that machine cost as well as carbon. And if you move that from China to France, as an example, that has a different carbon capture. So the same machine could run for an hour, but have a different carbon capture around, because France uses more nuclear and typically China is more related to coal-fired or interconnected.
All right, well, great, thank you. I think that'll wrap up our Q&A. I do see a few thank yous coming through from the attendees, so I would like to pass those on their behalf. And I would also like to thank you, Victor, and of course, John, for answering some of these questions and for presenting today. So thank you both very much.
Thank you, everybody.
And we'd like to thank our attendees for joining us. You will receive a follow-up email with a link to view the recording of today's session. So of course you can watch that again, and feel free to share that with your colleagues and higher ups as you see fit. If you think of any additional questions after we close, you can email me directly at sarah.allspa@siemens.com, and I can forward you or point you in the right direction. You can also come back into this room at any time, and you can access the Q&A as well as the recording, and you can submit your questions there, and I'll be notified about that as well. Quick reminder to join us for Realize Live. If you can, head to realizelive.com for more information and to register today. If you have a project or a problem immediately in mind, feel free to use this QR code. It'll take you to a list of phone numbers, so you can find the phone number for your location to get connected to talk to someone directly that can help you out. So this is also in our related resources, so feel free again to bookmark this before you go, or you can come back in here and grab that link at any time. But this concludes our webinar. Thank you all so much for being here. We hope you have a great rest of your day, and we'll see you around soon. Thanks, everyone. Bye.